Good afternoon everyone, I am Mr. Ish. Thank you for joining me for this video. We have a very interesting topic today. Congruent arcs from congruent circles give rise to congruent chords. In terms of an application, that's what we're looking at. But what exactly does this topic mean? If you have a circle and it's identical to another, they're congruent, and you can just draw an x and y plane in both of these. If you pick like a certain arc, let this be an arc. Both of these arcs, for both of these circles, these arcs should be equal to each other because they're from congruent circles. If you draw a chord from this point to this point, you have a chord. You're determining this chord right here should be equal to that chord right there. Likewise, if you were to pick an arc right over here and it's similar to this one over here, the chord generated from there to there, in both instances, this chord right over here and this chord should be equal. Congruent arcs from congruent circles give rise to congruent chords. And a very important application or outcome of this property is this. The cosine x plus and minus y, the cosine sum and difference formula. The very important trigonometric identity that you know of, cosine x plus y and cosine x minus y, we'll look at that. It's very interesting. Before we do that, anytime you have a unit circle drawn, imagining that the unit circle was x squared plus y squared is equal to 1, where the radius here is equal to 1. You see this right here, 1. If you were to pick a point over here and connect it by means of this 1 radius, having a dimension of 1, you know you're looking at an x and a y dimension. The angle here, theta, you can do cosine theta is equal to x over 1, then x is equal to cosine theta. You cross multiply. Sine theta is equal to y over 1, opposite over hypotenuse, and y is equal to sine theta. So then by means of this specific point, it's made up of two coordinates, x and a y, but they're cosine theta and sine theta. You see how we've determined the coordinate point for this specific point over here. Likewise, anywhere on the circle you can determine the points by means of this. So keep this in mind as we look through this particular application over here. You are all aware of this. Cosine x minus y, the cosine difference formula, is always equal to cosine x cosine y plus sine x sine y. We can derive all of this from that particular application we're talking about. Start with drawing a unit circle. You have a radius equal to 1. You have a point here, 1, 0. Then you've arbitrarily picked 2 points, point A and point B. If you look at this specific arc over here, and we were to generate another circle having the exact same dimensions, we don't have to do that. We can do everything on the same circle. So we're looking at congruent circles. They're just superimposed on each other. If you were to look at the chord between these two and take this specific chord and that specific arc and translate it down over here, you're translating it so that you're looking at from right over here. The difference between point A and point B would translate right here as point A minus B. This arc should be equal to this arc. This chord here should be equal to that chord. And if you can show all of that, you will derive that formula right over there. Let's do this. What's a point A? Point A over here, based on what I was showing you with the unit circle, is going to be, you know, cosine A and sine A. Here A represents the angle. What's point B? Point B is going to be cosine B and sine B. I'm just using lowercase letters. You already have a point 1, 0. What's point A minus B? It's going to be cosine of A minus B, comma, sine of A minus B. You're seeing how all of these points are coming out? It's not too hard. If you look at the distance of the chord from here, it should equal to the distance of the chord from these two. This distance of the chord from point A to point B, this chord, which is this horizontal line, should equal to the distance of the chord from right over here, which is this right over here. If you can calculate the distance of these, you will easily show that formula. And you know the distance formula, you have y2 minus y1 whole square plus x2 minus x1 whole square. That's the distance formula. That's exactly what we're talking about. What we're saying here is the distance from point A to point B should be equal to the distance from 1, 0 up to this right here, point A minus B. This distance should be equal to that, and you can utilize all of that by means of this formula. And we have all the coordinates here, x, y, x, y, x, y, x, y. We have it all. Put everything here to the formula. From point A to point B, you have x1, y1, x2, y2. You'll have here sine B minus sine A whole square plus x2 minus x1, cosine B minus cosine A whole square. should equal to the distance from these two in terms of the chord, and we can do that. You can do right over here sine A minus B minus 0 whole square plus you'll have cosine A minus B cosine A minus B minus 1 whole square. Y2, Y1, X2, X1, that's how everything is played out. If you were to square all of these, you can eliminate the radical. And I'll eliminate the radical, and by just doing the square technique, we've eliminated the radical. We don't have to rewrite it all. Just by doing this little mental step, we've eliminated the radical. The radical is gone. Now what we have to do is open it up. But to open it up, I need space. So I'm going to erase all of this you see over here. You know this. Point A, point B, the coordinates. Point A minus B, the coordinates. And 1, 0, the coordinates. We'll erase all of this. Everything here is radius is equal to 1. Unit circle with a radius of 1. We have to open all of these. These are like A minus B whole squares. When you open this, you'll have a sine square B plus sine square A minus 2 sine A sine B. You know A minus B whole square is A square plus B square minus 2AB. Let's open this up. You'll have cosine square B plus cosine square A minus 2 cosine A cosine B. We have to open this up, but this minus 0 is meaningless. You can erase it. You're just looking here at it as sine square A minus B. That's all what it is. But this right here is going to require a little bit of work. You have A minus B whole square. It's going to take a little bit of space, so let's do it. I'm going to bring it right over here. Cosine square A minus B plus 1 minus 2 cosine A minus B. That's exactly what it is. Now let's think about a good property, trigonometric property. Sine square theta plus cosine square theta is always equal to 1. We have something like that. Keep this in your mind as I start cancelling things out. I have sine square B, I have cosine square B. This is like sine square theta plus cosine square theta. They become a 1. I have a sine square A, cosine square A. This is also similar to that property there, equal to 1. Then I have this minus 2 sine A sine B minus 2 cosine A cosine B. Now keep that same property in mind. Sine squared theta, cosine squared theta. Here theta is A minus B. That doesn't matter. Sine squared theta plus cosine squared theta. That's a 1. We have that 1. Then we have another 1. We have that 1. Then we have this minus 2 cosine A minus B. Let's start cancelling things out. I have a 2 over here. I have a 2 over here. If you take these 2 over here, it'll cancel out. These 2's will cancel out. Now I have minus 2, and minus 2. Hit everything over here with a times minus 1 over 2, and you'll get rid of these minus 2's and everything will become positive. You'll have sine A sine B plus cosine A cosine B is equal to cosine A minus B, and this right here is your identity. So what if I'm not using X and Y's? A's and B's are just as good. You can rewrite this again in the proper order. Cosine A minus B is equal to cosine A cosine B plus sine A sine B. It could be cosine X minus Y is equal to cosine X cosine Y plus sine X sine Y, and that's the identity right over here, and it's proven for you. We have derived it for you using that property. Congruent arcs from congruent circles give rise to congruent chords. Here the congruent circle would have been you showing point A and point B on one circle, and then on the exact same circle you're showing point A minus B to 1, 0. These two on two separate representations, but I've just superimposed everything onto the same circle. From this you can now easily derive your next identity. Let's look at this now, the sum identity. Cosine x plus y is equal to cosine x cosine y minus sine x sine y. Since we have derived this for you, you can easily derive the sum from right over here, and this is how you'll do it. It's very easy. You're looking here at this. You're looking at a minus minus b. And then you plug this in right here into this formula you see. This right here is equivalent to you just looking at cosine A plus B, because the minus minus becomes a positive, and now you have your sum right over here. This right here will give you your identity that you want. You just have to work it out. This minus B will be plugged here in places of where the B was. You have cosine A, then you have cosine of a minus B, plus sine A, and then you have a sine of a minus B. Remember, cosine is an even function. For cosine, minus x is always equal to cosine x because it's an even function. However, the story is not the same for sine. sine minus x is equal to minus sine x, because this is an odd function. Remember, cosine is even, sine is odd. F of minus x is equal to f of x. F of minus x is equal to minus f of x. These are your tests for even and odd functions respectively. Utilize that function right over here. You'll have cosine A, cosine minus b will become cosine b, positive. This minus is going to translate itself right over here, and it'll affect everything afterwards. Sine A and sine b, because sine is an odd function, you have this. And this right here is your identity in terms of the sum formula. We have the difference formula, here we have the sum formula, all coming from that properties of that specific circle, the chords, the arcs, congruency, all of that giving rise to both of these. And you're seeing them right here before you. And keep this in mind, and this is pretty much what I wanted to show you in this particular video. How you can go about deriving this and how you can go about deriving that once you've derived the difference formula. And that's it for this video. Thank you for watching. Have a great day. Bye.